So I want to provide you with a small example of this direction and concavity. So I'm going to draw a little picture here for you. So suppose I have a graphical representation. I have a vertical axis that is going to be measured in degrees Fahrenheit, and a horizontal is going to be days after January 1st. So let's talk about what the curve could possibly look like, or what the graph could look like. Well, I know that it's fairly cold at the beginning of the year, and it might get a little bit colder, but then eventually in the summertime it goes back up, and then it comes back down back to December 31st. So I'm going to call this 1231 and this 1 1. Those are going to be my horizontal axis numbers. Now the actual numbers over here, I don't really care about. It's going to depend on where in the world you are. But let's say we're in North Carolina, and this might be a description of it. So there are different parts of this graph. There's a peak right here. There's a minimum right here. And they have different properties. In this particular section of the graph, this is a decreasing function. In other words, the temperature is getting colder. In this part of the graph, it's an increasing function. So I will abbreviate this with decreasing and this with increasing. And then if you look over here, I also have a decreasing idea. In other words, as I move from left to right, the temperature values go down. Now, another thing I want you to notice is when we talk about concavity, I have different concavities here. In fact, there's a place right here where the concavity is going to change. This part of the graph, this is concave up. But this part of the graph, all the way to about here, this is concave down. This part of the graph, this is concave up. And I'll usually abbreviate it with a C and a U. Over here, I'll abbreviate with a C, D, concave down. Now, there's lots of ways to determine things about concavity. One thing I like to think about is a concave up curve looks like your curve y equals x squared. And there's two portions of it. There's a decreasing version, and there's an increasing version. A concave down situation looks like this. It's like the downwards facing parabola. In other words, y equals negative x squared. And again, there are two versions of it. There's an increasing version and a decreasing version. These are the possibilities that we have for this concavity. Well, except for a straight line. So this part of the graph, right here, this is concave up and it's increasing. It kind of looks a little bit like this part of the graph here. But this part of the graph, from here to here, I know it's decreasing and concave down. That kind of looks like this section over here. So this is a quick introduction to direction of a graph, increasing and decreasing, and concavity, concave up and concave down. We'll be talking a lot more about these topics in a later video. So in the problem that I have here, what I'd like you to do is to label the increasing concave up, increasing concave down, decreasing concave up, and decreasing concave down intervals. So I hope you had a chance to do this yourself. So here's my solution. Increasing concave up is any graph that's going to look like this. Increasing concave down is a graph that looks something like this. Decreasing concave up, decreasing concave down, they all look like this. So I'm looking for this particular type of graph in this picture. And I see that it goes from 3 pi over 2 to 2 pi. 3 pi over 2 to 2 pi. This piece, well, that looks like the first piece here. 0 to pi over 2. This graph looks like the graph between pi, pi, and 3 pi over 2. This piece, pi over 2 to pi. I hope that was helpful for this particular problem. In this problem here, I would like you to label the increasing concave up, increasing concave down, decreasing concave up, and decreasing concave down intervals. Give yourself a few minutes to do this, and pause the video. I hope you had a chance to attempt this problem yourself. So again, increasing concave up looks something like that. Increasing concave down looks like that. Decreasing concave up looks like this. Decreasing concave down looks like this. So this particular part, where do we see this? Well, I see it in this part here. Do I see it anywhere else? I don't think so. So this, I'm going to label minus infinity to -1. Do I see this particular graph in any of these sections? Well, does not exist. DNE. This particular graph, do I see this here? Well, I actually see it in 2 spots. So the way I'm going to write this is going to be -1 to 1 union 3 to infinity. This particular graph, I believe it's right here. And that's going to be from 1 to 3. I hope that solution was helpful. This problem is a little bit different. I am giving you the intervals for the direction and concavity. What I would like you to do is to really sketch a graph with the following. There is more than one answer for this, so pause the video now. I hope you had a chance to attempt this yourself. In this particular problem, I'm asking you to kind of go backwards here. So I'm going to do the same thing I do in many of the problems. Increasing concave up looks like this. Decreasing concave up looks like that. Decreasing concave down looks something like this. Increasing concave down looks something like this. So how do I sketch a picture? Well, what I need to do is take these four shapes and just kind of put them together. So, nothing to scale here. I got my first piece, my second piece, my third piece, and my fourth piece. Now, in order to label this a little bit better, I am going to put a horizontal axis and a vertical axis. I'm going to label some points on here. This is about -2, this is about 2, and that's it. I hope this solution was helpful.